Hello and good day everyone, welcome back to my YouTube channel, and in this video we are going to talk about searching algorithm. More specifically, the linear search and the binary search. So before we get started, let's go ahead and make a program that implements the two concepts. Alright, so now we have our program right here. So quick overview, our program has one class, the LB search. Inside our class, we have three methods. Our main method, and the other two, we have the method for implementing our linear search and binary search. So as usual, our compiler will read first the code that's inside our main method. So we create a scanner, we name it SC, in order for Java to receive inputs from the user. So in order for us to create a scanner, we import this utility scanner over here at the top of our class. So once we have imported that, we can now freely use the scanner. So after we have created our scanner, uh, I have created a set of variables here that we will be able to use later. We have the integer type variable search, the characters which are sorted or not, and A or B, and another integer type variable answer which I initialize its value to 0. After that, we go straight to printing out this text, enter the size of the array. So before we continue, let's just first run this thing. So as you can see, the very first thing that we can see in our program once we have run it is the very first thing that we have printed, which is the enter the size of the array. So I'm gonna put 5 here. So once I've inputted 5, I can enter 5 elements or 5 numbers I want to put in my array. So I'm gonna put 1, 2, 3, 4, and 5. So we have entered 5 elements. Now I want to let's just say that I want to know what index is the value 5. So what is the index of the value 5? I want to search where it has been put. So I'm going to type in 5, and we get to choose your desired searching technique. So before we can choose in this program, before we can choose the desired technique, we need to our program needs to first know if our array is sorted or not, because as you can see, the binary search can only be done if our array is sorted. So it needs to know first if it's sorted or not. So in this case, 1, 2, 3, 4, 5 is sorted, so I'm going to put yes, and only then will our program give us the option. So option A will be the linear search, option B would be the binary search. First, I'm going to choose the linear search, A, and as you can see, it displayed the elements that I have created earlier, 1, 2, 3, 4, 5, and also it displayed the answer that I'm looking for. So the value that you search for is in the index or location 4 of the array. And thank you for this program. So that is the end of our program. So let us trace why did our compiler got that output. So as I said earlier, the very first thing that our output can see is the entire size of array. So I put in 5, and because we put in this, we call the scanner here, so that's why Java let me input this value right here. So this value 5 has been stored in the in this variable choice. So I forgot to mention earlier, but this variable choice, I put it here outside the main method. So I put it static, and also I have initialized its value to 0. So choice has now a value of 5. So after that, I created an array. So I created an array named R, and I set its length to whatever the value that we had inputted earlier. So the value of choice is 5. So which means that our array can contain 5 elements. That is why when we print out this we print out this text, enter choice, so enter 5 elements. So this has been printed out, and for this element to display, we run it inside a for loop. So we create a for loop, we create a variable I, initiate its value to 0, and create a condition where we are to continue in our for loop if our value I is less than if the value of our I is less than the value of choice. Right now I is 0, so and our choice is 5. So which means 0 is less than 5 is true. So which means we are to continue. So we did another scanner call here. So it allows us again to input something in our program, and anything that we had entered will be stored in our array and in a specified index. So array I is in 0. The value of our I right now is 0. So array in index 0, I have inputted 1. So array index 0 has a value of 1. We loop back again. We loop back again. We increment I. So I is now equals to 1. I is less than 5, which is still true. So we run it again. So this time array is in index 1. Array index, this is now array index 1, and this is this is a scanner call, so we can input another value. So I inputted value 2, and we'll loop again until the value of our I will become 5 and the condition will become false. So that makes this loop right here is responsible for us to enter the values of our element. So once we are done with that, we proceed to the code next to it. So after that, we ask the user, enter the value you want to be searched. So that enter the value you want to be searched. I want to search the value 5. But before I get to type this number 5 right here, again I did another scanner call, and any value that I input in this will be stored in the search variable, which I had declared earlier here. So that's why we got this line of output here. So after that, again we implement the next code. So system.out.print, choose your desired searching technique. I choose your desired searching technique, and I put a /n here because I don't want this to be a very long sentence. So please take note that the binary search is only applicable to sorted array. I put it in another line. That's the purpose of /n. And is the array sorted, yes or no? I put it in another line. After that, I did another scanner call, and any value that I entered will be stored in the value and the variable named sorted or not. So this time, as you can see, it is kind of different from our previous scanner call because this variable is an integer. However, this one is a character, so it can only process one letter. So that's why we have this extension right here. So because of that, we are able to type in this one right here, N or Y. After that, the real game starts. Now, after implementing this code right here, we proceed to our if statement. So inside our if statement, we have a series of conditions where we are to continue if the data in our sorted or not variable is equal to the character Y and the character Y, but the small type of it. So this condition right here allows us users to type in a big Y or a small y, and the program will still run. So I type in Y here. So that is why we get to continue the code which is inside of it. Inside that, we get to print this statement right here. These various print statements. So menu and enter your choice. Menu, linear, binary, and enter your choice right here. So as you can see again right here, I was able to input a data because in my code I did another scanner call, which is the same as earlier, a character. So any data that I typed in will be stored in the variable A or B. So I typed in A. Now after that, I have created a switch statement because I want my program to respond according to what I typed in my choice. So I created a switch statement. I have in the parameter here, I have entered the A or B variable because the next code that will be implemented will depend on the choices that I've made here. So inside, I created two cases. Case A. So in case A, the variable answer, its value will be equals to the linear method, and I want to pass in the parameters array. So the parameters, which is my array name R, and the value of my search. So after that, as you can see, in enter my choice, I have selected A. So in case A right here, what we have is linear. So that counts as a method call. So we jump to linear. here, and we created parameters for the array so that this method will receive the data of our arrays here, this array. So this one, this will receive, this parameter is the one to receive our array. And another declaration, int num. This num will receive the value which is in search, because that's not the right, in search, because that is the parameters that we have set. So in our linear method, I declared another variable number and set its value to the array, to the length of our array. So the length of our array is 5. The length of our array is 5, so 4. So 4 in, so after that, after setting the value of array, after setting the value of number to the size of our array, which is 5, so number has now the value of 5, we jump to our for loop that I have created. So inside the for loop, I declared another variable I, set its value to 0, and create a condition where we are to continue if the value of our I is less than our number. I is 0, number is 5, so 0 is less than 5, it is true, which means we are to continue. So if our array, our I is still 0, so if our array index 0 is equals to num, then we return I. So let's see, array index 0 is equals to num. What is the value of our num? The value of our num is equals to the value of our search. What is the value of our search? The value of our search is the value that we want to search earlier. So enter the value that you want to be searched. It is 5. So this means that this statement right here, this condition is false, so we skip that. We loop again, we increment I, we loop. This time I is equals to 1. 1 is less than 5, which is still true, then we proceed. So we go back in our if statement. So we are to continue if our array in index 1 is equal to the value of num. Our value of num is currently 5. The value of our, so these two values doesn't match, so which means again that it's false. So we skip this return and loop back, increment I is now 3. 3 is less than 5, still true. So array index 3 is equals to the value of num, which is 5, still false. So loop again, increment I. This time this is 4. This time this is 4. So I is less than 4 is less than 5, true. So the value of our array in index I, so our array that we have is, this is the index 0, 1, 2, 3, 4. Index 4, and our value of our num is 5. So which means it is equal. So we return the value of I. So which means we return since this condition right here is true, so we return the value of I. The value of I right now is 4. The value of I right now is 4. So we return it. So once we have returned it, we jump back to our switch statement. So right now, the value of our answer right here is the value that we have returned earlier. We have returned I, which is 4. So now this answer has the value of 4. This now has value of 4. After that, we go into this if statement again, but this, as you see earlier, I have entered y, so automatically this will be, we will neglect this first. We will not implement that because it is, we are only to continue here if what we have entered is n. So now, after all of that, we're going to print elements in the array are. So just like here, elements in the array are, and again we traverse it in order to display our elements in our array. We traverse it in our for loop. So inside our for loop, we declare I, set its value to 0, and we do a condition where we are to continue if the value of I is less than the length of our array. So I is equal to 0, the length of our array is 5, so this is true. So 0 is less than 5, true. We are to print system.out.print the element of our array which is in index 0. We print 1 because 1 is in index 0. So after that, increment I, traverse back, loop back again. I will become 1. 1 is less than 5, true. So print array, which is now, our index is now 1. So we print 2 because 2 is our index value 1. So we just loop it again and again until we have printed all our elements, and until our for loop, and until the condition of our for loop will become false. After that, I want to create a new line so that my output will not continue here and will continue to a new line. Now after that, I created another if statement. So here it says here that we are to continue if the value of our answer is -1. Remember that the value of our answer earlier the value of our answer is the value that we have returned here. So the value of our answer is the value that we have returned earlier from our linear method. We have returned earlier the value of 4. So naturally, the value of our answer would be, the value of our answer variable would be 4. So here, we are to continue in the if statement if the value of our answer is equals to -1, which is false. So we disregard that, we jump to else. That's why we printed the value that you have searched for is in index location answer. So the value of answer location 4 of that array. So that's why we got this output right here. So this was the answer for our search earlier, and we printed this thank you statement. So thank you for using this program. Alright, so that's basically how you implement linear search in Java. So I want you guys to look at here. I'm gonna put again 5 elements of my array. So this time I'm not going to sort it. Okay, I'm not going to sort it, and the value I want to search is 3. So now I'm going to choose no because my value is not, my array is not sorted. So if we go back here in our code, we have the if statement that we used earlier because this is for when I type y or yes. But now we have type in no, so we disregard this block of code and start here. in this if statement. So we are to continue if sorted or not is equals to the big letter N or small letter n. In my case, I chose no because this is not sorted. So again, we print this menu here. This menu is printed, and I want my program to ask, just like earlier, to ask me to enter my choice if I want to use it in linear or binary. But I'm going to choose linear again. Because I want you guys to see how it works. That it still works even if our array is not sorted. So as you can see, we had the same output. Elements in the array are. So I inputted A. So just like earlier, we did a linear, a method call in linear jump, and we do basically what we did earlier, and we return the value until we return the value of the answer, which is again 4, because 3 is located in index 4. 0, 1, 2, 3, 4. So we return the value 4, store it in the store it in the variable answer, and then we printed another line. After that. Just like earlier, we displayed the elements. We traverse each of them into our for loop in order for them to display one by one, and then print another line. Do another traverse to another if else statement again. Since our answer is not equals to -1, we print else. That's why we got this. So that's how linear search work. Now let's go ahead and see what we can see the concept of binary search. So I want to run a program again. I'm going to run my program again, and this time, let's try first a sorted array. So again, 5. The size of my array is 5. I'm going to put in 1, 2, 3, 4, 5. So those are the elements inside my array. The value that I want to be searched again is 5. And is my array sorted? Yes. This time, instead of A, I'm going to choose B for binary search. And as you can see, we had the same answer. It is located in index 4, but it has a different binary search has a different way of getting that answer. So let's see how our compiler got that output. So as usual, we go into our main method. We basically do what we did with our linear search earlier, and we made this whole thing here. So this is basically the same as linear earlier, the linear search. The only difference is when we get through here. So I've typed in Y. Excuse me. So I have typed in Y. That's why we proceed in this block of code. So we print again the menu. We enter a choice, and enter your choice. The program asks us to enter a choice. This time I chose B. So in our switch statement, I have chosen B. That's why this is another method call. We jump to um, just like the linear search, we have passed in I want to pass in the value of our array and our search. So these are our parameters. So we do a method call, jump to the method called binary. We have it here, and we have this following parameters that will receive the parameters that we have put in earlier. So inside our binary method, we have declared number, set its value to 0, and did another variable r, and set its value to the length of our array after we minus it to 1. So the value of array, our array length is 5, we minus it with 1. So right now the value of the variable r is currently 4. So in our while loop, so after that we do a while statement. So inside the condition of our while statement, we are to continue if the value of our number is less than or equal to the value of our I. The value of our number is 0. The value of our r is 4. So 0 is less than or equal to 4 is true. So that's why we continue. Inside the while loop, we declare another variable m. We set its value to the value number after this formula right here. So keep in mind that this formula right here is how we can define the middle element of our array. So why do we want to do that? Because how binary search works is that in our lines of array, we will search the mid of it. If we search the mid, we compare it to the value that we want to search. So if the value that we want to search is greater than our mid, so we disregard the lower numbers and we focus on that. Then we loop back, do another mid, search, we found the mid, compare it again to the value that we want to search, do the whole process again until we find the value that we want to find. So m is equals to number plus r minus number divided by 2. Currently our number is 0. Currently our r is equals to 4, and so 4 minus 0 equals 4. 4 divided by 2 equals 2, plus 0 equals 2. So our m has a value of 2. So after that, we go inside our if statement, where we have a condition where we are to continue if the value of our array and in index 2 is equal to the value of num. So index 2 0 1 2. So as you can see, our program managed to find the mid of our array, which is in index 2. And after that, we have compared it to our num. The value of our num is the value that we want to search. So our mid is 5. Our mid is 3, but the value that we want to search is 5. So which makes this statement false. So we jump into the next if statement. So here we have a condition where we are to continue if our array in index 2 is less than our num, or is less than the value that we want to search, which is 5, which makes this true. So we implement this code right here. So we set the value of our number to m plus 1. So m plus 1, the value of our m was 2, we added 1. So the value of so m now is 3. So the value of our number would become 3. The value of number would become 3. After that, we loop back to our while. So this time, instead of having 0, the number will become 3, r will remain 5 because it is the length. R will remain 4 because it is the length of our array after we minus it with 1. Then find the middle again. We find the mid again. So earlier we set the number to 3. So 0, 1, 2, 3. So this is now our new low. So after that, after we go back, after we traverse here, this condition is true. We go here, find another, find another middle. Since the value that we want to search is 5, so we just pretty much ignore this part right here. So now our new low again is the value of 4, which is in index 3, and we search for its mid. Now m is equals to number, so our number now has a value of 3. So r still has a value of 4. 4 minus 3 equals 1. 1 divided by 2 equals 0.5 plus 3. So that would make it 3.5, which will be read as 3. So m has the value of 3. So we run it again in our if statement. We are to continue if the array in index 3 is equals to the num. Again, it's false because index 3, it has the value of 4, and the value that we're looking for is 5. So skip that, jump to the next if statement. We are to continue if the element of our array, which is in index 3, is less than the value of num, or the value that we want to search, which is true. So again, we do this, we run this code inside this if statement again. So number, currently our m is 3. We add it by 1. So now the value of our number is 4, because 3 plus 1 is 4. We loop back, our number is now 4. 4 is less than or equal to r, makes it true. So we find the mid again. So m is equals to number is now 4. So r, 4 minus the value of our r is 4. The value of our number is 4. So 4 minus 4 equals 0. 0 divided by 4, 0 divided by 2 equals 0. So 0 plus 4 right here equals 4. So m is the value of m is 4. So we go back to if statement. We are to continue if the element of our array in index 4 is equals to num. Remember, index 4, 0, 1, 2, 3, 4. So the element in the element of our array in index 4 is 5. That makes it now equals to num, because our num is 5. So which means we return the value of m, which is 4. Return the value of m, which is 4. So we go back, we jump here, we return it, answer is 4. So the value that we have returned in our binary is 4. So which means the value of our answer here is 4. After that, we basically do what we did earlier with our linear search. So elements in the array are, we do a for loop so that we can display the elements that we had entered earlier. So this right here will display each of the element one by one. That's why we had it here. So just perform, it will just run like we did, like how we run it earlier. Then we print a new line, then the value that you search in the index location. We print a new line, then here in the if statement, we are to continue. In the if statement, it has a condition that we are to continue if the value of our answer is equals to -1. The value of our answer is 4, so we jump in else. So we print this line of code, this block of code here. The value that you search for is an index or location, and we print the value of answer location 4, then continue of the array. So that's why we got this answer. The value that you have searched for is in index or location 4 of the array. So that's the answer that we want. And we thank you for this program, for using this program. So that's pretty much the concept of binary search. That's pretty much the concept of binary search. But I want you to see how our program behaves if we try to push an unsorted array and try to push it inside and try to do a binary search on it. So remember, the reason why binary search only runs on sorted elements is because it finds the mid of our elements and compare it to the element that we want to search. So how can it find the mid if it's not sorted? So that's why it's important that we sort it. So I'm gonna create another example here, array 5 again, but this time I'm not going to sort it. So the value that I want to search is 6. So choose your desired searching technique. So first, again, it asks if my array sorted. No, I'm going to put it no. This time, instead of linear, I'm going to choose B, binary. So that is what it's going to print. Binary search is not applicable because the array is unsorted. But why did our program behave like this? So in order for us to do that, this line of code here is basically just like we did earlier. The only difference is here in our if statement. So we have entered n, so we skip this block of code. We will traverse through this code right here. As you can see, we have printed the menu and all the other statements that we have printed. We chose B. So in our A or B, when we chose B, so inside the B, so in this here, instead of doing a method call here like linear, we do a system print where if we click B with arrow and if our array is unsorted, then this will print binary search is not applicable because the array is unsupported. That's why we got this output right here, and it will print a new line and it will loop back to enter a choice because we did if you can see or if you have seen earlier, we did a do while statement here. So if in our while statement we have a condition where our program will continue to loop if our user will input B. I have inputted B in this block of code, so that means this will print and the code will loop back until we input another letter which is not B. So now this is why our program asked us again to enter another choice. So this time I'm going to enter A. We got our answer. So that's basically it. Oh, and one more thing. So our program will, let's say we do 5 again. 1 2 3 4 5, and this time let's say that I want to search the value 6. Yes, and A. So element not found, so it will print element not found. So this output right here, this basically is the same even if you pick linear or binary, because right here, after we have implemented everything at the top, after we get right here elements of the array are, we display the elements, we traverse it in our for loop, we print a new line, and then in our A, we create A. So I'm gonna traverse this for you so you can understand more. So inside our yes, in our yes, we call the linear because we input A. So linear, then so array, and this value that we have passed in our parameter is 6. So we created, we declared the number, we declared the variable number, set its value to the length of our array, which is 5, for, then we traverse it through a for loop with the condition, we declared I and set its value to 0, and we did a condition where we are to continue if we are to continue if the value of our number, if the value of our I is less than the value of our number. So 0 is less than 6, true. 0 is less than 5, true. So we run it. So inside our for loop, we have if statement where we are to continue if the value of our array in index 0 is equals to the num. Our num is 6, so false. Loop back, increment our I, and we loop back again and again until our I reaches to 5. Until our I reaches to 5. So 5 is less than 5. It makes this false. So it ends the process for our for loop. So which means we jump here. We return -1. That is why when we jump right back here, if we are asked if we once we face this if statement right here, answer is equals to -1, then system.out.print element not found. So this text will be element not found. So that puts an end for my discussion in this video. So I hope you learned something, and I'll see you more soon in the next video. Thank you so much for watching, and have a blessed day.